Hello, and welcome back to the UAS Magazine podcast. I'm your host, Danielle Piekarski, and today we have two guests joining us. We are welcoming Laura Garcia-Junceda from UAV Navigation and Carlo Sarto of Qascom. Thank you both for being here today.
Thank you, Danielle. We're very happy to be here.
Thank you, Danielle.
All right, so let's get started. Carlo, if you want to go first, we'll just have you tell us a bit about yourself and your company, Qascom.
Thank you. Very quickly, I'm head of security engineering at Qascom, where I've been working since 2008. And my expertise is in system engineering, security, and applied cryptography, mostly related to communication and navigation satellite domain. My company, Qascom, is based in North Italy. It's an aerospace company and was founded in 2004 and was initially focused on the security of satellite-based navigation. But over the time, we expanded our area of expertise, and now we are working with the agency, the European Space Agency, the European Commission, for what regards our European Global Navigation Satellite System, Galileo, and for which we provide expertise engineering consultancy for what regards security. We also have a number of products, mostly our GNSS receiver, and I'm very pleased also to mention that we are going to participate to our Artemis mission to the moon with our GNSS receiver. Leave the floor to Laura.
Thank you, Carlo. Well, so I am aerospace engineer from the Polytechnic University of Madrid, and I have been part of the flight control team of UAV navigation for the last 5 years. I'm specialized in the area of estimation, and I'm responsible for sensor validation and also for the development of sensor fusion-based algorithms for the navigation solution of UAV navigation's products. More focused on UAV navigation, it is a private Spanish company located in Madrid and founded in 2004, which is specialized in the development of guidance, navigation, and control solutions for UAVs. These flight control solutions have been used by a large number of national and international operators in many different platforms, such as high-performance tactical unmanned planes, aerial targets, small and medium UAVs, and also rotary wing platforms. Furthermore, UAV navigation is part of the multinational OSNMAplus group, which is a Spanish group with a large experience in the areas of security, defense, and also aerospace sectors, and with clear synergies with our objectives and also lines of development. Last but not least, UAV navigation also participates in several R&D projects, some of them international projects, such as the OSNMAplus, which is funded by USPA and led by Qascom, and which we will talk about in more detail, thanks to which we are here today.
Great. So both of your companies, UAV Navigation, recently partnered with Qascom on the OSNMAplus project. What can you tell us about this project?
I will start from the beginning. So in 2019, USPA, the European Union Agency for the Space Program, opened a tender to fund the development of new technologies that were making use of two new services offered by the Galileo, the European Global Navigation Satellite System. The first service is OSNMA. So it's a service provided by the satellite system. It's a free-of-use service, which basically adds an authentication layer in the data transmitted by the satellite in order to increase the resilience against cyber threats. This is a very unique feature that is offered by our European GNSS system. How it works. So basically the satellites transmit information to the user, to the receiver, in order to let them being able to calculate the orbit or the position of the satellite very precisely. And this information is then used again by the receiver to compute their position by knowing the position of the satellite and the times it takes the signal to come to the earth, the ground. It's a kind of triangulation of the signals. But with OSNMA, which stands for Open Service Navigation Message Authentication, the information that is transmitted by the satellite is complemented with a kind of signature mechanism based on cryptography, which can be used by the user to verify the authenticity of the data. The second service is so-called INAV improvements. INAV are, again, the navigation data transmitted by the satellites and have been complemented with a new set of data which aims at optimizing the reception performances in disrupted environments, urban canyon, the cities, and so on. So this will basically improve the performances of the navigation. So as Qascom, we have been working on this concept of security of the satellite and authentication of navigation data since 2004. And we have been working also with the European Commission in defining a service for Galileo. So then when this tender was open, we were very willing to develop our technologies based on that. We did a proposal and we had UAV navigation on board as we wanted to develop technologies that later were used for drones navigation. And then on board we also have UAB, which is the Universitat Autònoma of Barcelona, which have a very good expertise in research and analysis. So this was our proposal to this tender, and we basically were aiming to develop several solutions, several technologies. The first one was a robust GNSS receiver, which was specifically designed to be used in space navigation, but as well in professional drones. Then we wanted to develop a kind of software library that was implementing these new services and was meant to be easily integrated in an already existing solution. So we developed already this technology and can be very easily integrated in microcontroller, existing GNSS receiver, computers, but even a smartphone. And last but not least, a number of connected services, kind of a server which is providing assistance information to users that have internet connectivity. Let's assume that you have a drone in a city with internet connectivity. With these services, you can obtain information against the trustability of the GNSS signal, and you can also improve your resilience against GNSS cyber threats.
Very interesting.
We already developed, yes. We already developed all of these technologies, and in a few, we are going to start experimentation beginning of next year. And during this experimentation, UAV navigation will play a big role because we are going to test this navigation solution in drones, and we will perform a lot of hours of testing and also simulate attacks.
That's very exciting. So how is global navigation satellite system-based navigation important to our daily lives?
GNSS is intended to provide positioning, but as well navigation in time. In fact, sometimes we abbreviate as PNT, position, navigation, in time, and is the most common way to calculate this information. And as such, the satellite positioning has become an essential service in our daily lives. It's used in all the form of transportation, space station, aviation, maritime, rail, road, and mass transit, but as well UAV. And since it's becoming essential, you have to just think what will happen if GNSS signal at some point were suddenly switched off. That would be a big problem. In fact, as the use of GNSS is becoming more and more prominent, and at the same time, there are also emerging technologies that are relying on it, such as, again, UAV, then also the need of having a reliable, precise, and trusted service is increasing. Specifically for this argument, I will let the floor to Laura, which has a more expertise on this domain.
Thank you, Carlo. Well, so for the aviation sector, it's true that since the beginning, the GNSS system has provided significant benefits to aviation and has also been an enabler for several improvements, both in safety and also operational efficiency. As a snapshot of the benefits that have been enabled in aviation through GNSS, and specifically the European introductions of Galileo and the EGNOS augmentation system, we cannot forget, for example, about the deployment of performance-based navigation, or PBN, and also precision approach procedures such as LPB. Also, space-based surveillance capabilities such as ADS-B tracking services are enablers of traffic growth and continue supporting new operations around the world. So in this sense, we could say that there is a natural trend on moving towards space-based aviation services, and this way taking advantage of the associated savings on infrastructure and also improvements on accuracy, availability, and also integrity levels. Now, focusing on the UAS sector, the GNSS is foreseen as the main navigation and surveillance tool for the open and specific categories. And otherwise, artificial vision sensors and, other non-GNSS based sensors will act in order to fill the gaps in the GNSS signal availability. This is because, in addition to its high performance, also its low weight, and even the ubiquity for open sky operations, the importance of the GNSS arises from the fact that it is very, very related to some specific functionalities that will be essential for most commercial applications, especially for BVLOS operations, in order to comply with the upcoming use-based regulations. So again, here we could say that the GNSS acts as a cornerstone for the operability of UAS, both in the present and also in the imminent future.
Okay, so going off of the airspace, what are some of the current challenges in designing guidance, navigation, and control solutions for UAVs?
Okay, thank you, Danielle. The main idea here is that safety remains the main priority and the biggest threshold for the massive eruption of UAS in multiple applications. Regarding the regulatory challenges, the technologies associated to the guidance, navigation, and control solutions must comply with the established quality assurance levels. And in this sense, a trade-off solution must be found in order to achieve it in an affordable way. But fortunately, we can see a clear trend in this direction thanks to the new EROCAI working groups and also the new European regulations, in which different categories are already identified based on the associated risk for the specific operation. And also quantitative criteria are beginning to be defined. So this will allow for the safe integration of UAVs into non-segregated airspace and also into the EU space. Now, related with technological challenges, systems on which the flight control system relies must be designed so as they meet with increasingly demanding operational needs in terms of accuracy, availability, continuity, and also integrity. And furthermore, they must be able to operate in a hostile environment where it becomes essential to provide the systems with the identification capability and also the necessary resilience to mitigate malicious attacks. And at this point, the GNSS systems play a critical role as they are generally used as one of the main sources of information for the navigation system. For the part, the high accuracy service and the OSNMA technologies for of the Galileo GNSS system aim to address the aforementioned challenges and even revolutionize the UAS operations in the near future. On the one hand, the Galileo High Accuracy Service, or HAS, aims to provide free of charge high precision point positioning corrections via the E6B Galileo signal. And on the other hand, the Open Service Navigation Message Authentication technology, also called OSNMA, is focused on providing an authentication mechanism for the GNSS navigation system in order to make the system robust against cyber attacks such as spoofing. And finally, I consider that also research should continue on combined technologies which allow for the intelligent fusion of different sources of information in order both to avoid simple points of failure and also the excessive dependence on one single system. And also new algorithms that allow greater autonomy and also decision-making capability in real time of the platforms are identified as a clear need in the future. And in this sense, the new advances in artificial intelligence and also computational and communication capabilities will allow onboard processing. And the way in which these communications will be protected, as well as the ethical implications that intelligent and autonomous systems entail, will be definitely key points to be addressed.
Thank you, Laura. Well, we are coming near the end of our time here, but do either of you have anything else that you would like to add?
Well, just my thanks to you, Danielle, and to the UAS Magazine. Really, thanks for this opportunity. And I also need to thank the Airspace agency and as well the OSNMAplus project team. So UAV navigation, UAV. If you want to know more about the project, we have a webpage for the project, osnma.au or .com. Finally, thanks to Laura.
Thank you, Carlo. Only for my side, I wanted to add that, we are impatient to see the results of the OSNMAplus project and also to make real use of the OSNMA service to provide more robust and also more reliable operations. And I joined to the thanks to USPA, to the OSNMAplus project team, in particular to Qascom and UAV University. And also thank you to you, Danielle, for giving us this great opportunity to participate with UAS Magazine and collaborate with our experience to the UAS community.
Yes, thank you both again for joining us on the podcast and for today's conversation. Again, we are joined today by Laura Garcia-Junceda from UAV Navigation and Carlo Sarto of Qascom. And thank you to our listeners for tuning in. If you or your company is interested in recording a podcast, please contact UAS Magazine. We hope that you enjoyed this podcast and we look forward to next time. Until then.